Hi, I'm James, this is Make and Malt, and today we're going to fix up the old drill. The problem I'd been having is that when I turned the drill on, immediately the fuse would blow. Now, I didn't know exactly what was causing it, but I thought I had a few ideas. When I took the drill apart, I checked everything up to the motor in terms of wiring, and it seemed to be working alright, so I've taken a bit of a gamble and got a new motor. I tried checking the resistance of the coils in here, and it does seem to be a bit off, so hopefully I'm on the right track. I did find a new motor that was a bit more powerful than the old one, and it's of a similar size, but the shaft on the new motor is shorter than the old one. To fix that, I need to machine up a new extension piece that will fit on the end. I've been looking through my stock, and the smallest piece of steel I've got that would be the right size is this big old chunk of EN8, and I don't really want to be wasting all that material to make a shaft. I have got some aluminium which is pretty much the right size, so I'm going to try making it out of that, and if I need to change it in the future, I will do. The other problem I've got to solve is mounting the motor. Now, the old one bolts directly onto this steel plate that then slides into the back, but the new motor just doesn't quite fit. I've got a couple of options, and either I'm going to do some milling out of these feet that fit on here, or I might fabricate something like a new plate to mount between the motor and the mount. I decided to make some new feet for the motor, so I found the centre of this aluminium plate and then cut it out using my 4x6 bandsaw. There are loads of different options when it comes to cutting metal like this, but the thing I like about the bandsaw is that I can just leave it to run and I can get on with doing something else more interesting. I don't have a set of triangular punches, so I'm just using a drill bit that's the same size as the hole. Once I've made an impression, I use a centre punch just to mark the hole before I start drilling. Now, I haven't got my drill press at the moment, so these holes don't end up perfect, but they're close enough for me. I also need to machine a recess for the head of the bolt. I used a similar trick to line up the hole using an end mill that fits into that hole I've just drilled, before swapping out to one that will fit the head of the bolt. Now, the problem I had here was that my DRO wasn't working, but luckily I can just use the scale on the side. And here's the finished result. You can see those stainless steel tubes I talked about earlier. I've done most of the machining on the pulley before, but I needed to take just a little bit more off. I'm using a boring bar, which I'd never used before, at least not with this attachment, so it was a great opportunity to learn, or at least practice, a new skill. The next thing I had to do was figure out where the feet would line up on the mounting plate to get everything in exactly the right place. To help do this, I lifted the drill table up and around so that it could support the weight of the motor, while I got it centred and at the right height so that the pulley would sit perfectly in line with the other one. Now, what you didn't see me do is scribe a line where that mounting plate offers up to the new feet, just so that I could take everything off and mark out the hole locations more easily here on the bench. And to make those marked out lines show up more easily, I used a black permanent marker. You can use layout flows if you've got it, but I haven't, so I used what I had. Hopefully you can see that those marks show up quite well on the aluminium. Now it's just a case of marking where the middle is, centre punching it, and drilling out the holes. Of course, it would be much easier again if my drill press was working. And this is the reason why. It does fit, it just takes a little bit of persuading. Or maybe quite a lot of persuading. But once I got a nut on the other end, it all tightened up and held everything in place really securely. The motor's now mounted and it's pretty solid. And even better, I've realised that I don't need to add an extra shaft on top of this output here. I was thinking of having the pulley the other way up, which obviously wouldn't make any difference. So I'm glad I don't have to do that. One downside, the electrical cable's just too short to reach into the box, even having the input over on this side. So I'm going to need to rewire it, but hey, less machining, more wiring. And you can see here I've taken off the side plate to get access to the switch. It's quite difficult to get at, so I think the easiest thing to do is just take it all out, and then I can do the wiring properly. The two earth connections had been crimped together, so I had to cut them apart, but annoyingly the cutters I had in my electronics toolbox just weren't sharp, so I grabbed some better ones. These are made by Knipex, or Nipex, or Knipex. Leave a comment below, let me know which one it is. Yeah, she needs some new teeth. These little things are crimp connectors. They're a really professional way to finish off your wiring. There's different colours based on different sizes of wire, and they can also carry different amounts of current. You just slip them over the end of the wire and then use what is effectively a special set of pliers just to ratchet it onto the end. And there we go. I've got a really strong, solid electrical connection that I can fit onto the plug. Once I'd done all the wiring on the switch, I had to wire up the motor itself. Luckily there was a connection diagram on the back of the electrical box. You might need to change some things over in the box as well, depending on whether you need the motor to spin clockwise or anti-clockwise. Luckily the way it came out of the box was perfect for me. I just had to connect up the live, the neutral, and put the earth connection onto a screw terminal inside. And at the end you can see that connector. Make sure you put that on before you do all of the crimping. Okay, moment of truth. We'll find out if it's the motor or if it was just this really cheap switch that needed replacing. Fingers crossed. Yes! Oh, I'm so glad. That means I've got my drill press back. No longer am I going to be drilling wonky holes by hand. Right, it's time to connect up the belt, check that the spindle still spins, and then put it all back together. Back in its rightful place. Now, this machine's been around for a long time, and it was my father's before mine, so it meant a lot to me to get it back working again. Aside from the fact it's an old machine, it's British made, it was actually cheaper than buying another import machine. So, glad to have it back, and I'll see you next time.